Hello everyone. In this video we're going to talk about pressure. Okay, if we look at any kind of fluid, be it a gas or a liquid, there will be a few key forces that is acting on within the fluid itself. So take for example this liquid flow over here across a solid surface at the bottom. Okay, there will be the first kind of flow will be the first kind of force will what we call the shear force. Okay, this kind of force, right, is acting along the direction of the flow. Okay, so they are acting against each other simply because at the different layer of the liquid, the speed is different. Okay, the nearer it is to the solid stationary surface, the lower the speed will be. So as you go higher and higher, the top layer will actually have the same speed as the top speed over here. So the differences will cause a force acting on the fluid itself. Okay, and this direction is along the direction of the flow. Another kind of force is the kind of pressure forces, and this kind of force is actually acting in perpendicular to the direction of the surface. Okay, so take for example the bottoms of solid surface. Okay, the force that is acting on the solid by the fluid will be shear if this is if the flow is in this direction, right? So the shear direction that the fluid is acting on the solid will be in this direction because it is dragging and there's a traction on the solid because the solid is not moving. Okay, and then there will also be a perpendicular force acting on the solid. Okay, perpendicular downwards by the fluid. This is called the pressure force. Okay, so we have a pressure force over here and a shear force over here. One is parallel, the other one is perpendicular. Okay, another name for parallel is also tangential. Okay, so the shear forces are acting in the tangential direction, while the pressure force is acting in the normal direction. Okay, another word for perpendicular is normal. Okay, so this is what we are going to focus on, pressure. Okay, but pressure, pressure is the definition of pressure is the force per unit area. It's the force per unit area. So it is a force divided by area. Okay, force, you know that the unit of force is Newton, whereas the unit of area is meter square. These are SI units. Okay, and this Newton per meter square, okay, can also be called pascals. Okay, so 1 Pascal is equals to 1 Newton per meter square. So this is the definition of pressure. Okay, the pressure force per unit area. And this area, let's see how we can describe. So if your solid surface is a single circular disc, okay, and there is a body of fluid on top, the pressure force acting by this body of fluid on this area, I can color it, will be something like this. Okay, this will be the pressure force. Okay, and this is your F here, and this shaded black region will be the area. Okay, that disc area will be the so-called area. So 1 Pascal will be the force divided by this area, 1 Newton meter square. Okay, and it is not enough just knowing that 1 Pascal is the SI unit for pressure, because a lot of times we do not just use Pascal. We use units like 1 bar. Okay, we also use units like 1 megapascal and 1 kilopascal. Kilo, of course, will be 1000 pascals. Mega, okay, is 1 million. Okay, usually we say 10 to the power of 6. So 1 million pascals. and 1 bar is related to 10 to the power of 5 pascals, which is 100,000 pascals. So these are the units that are commonly used, okay, apart from pascals. We will also talk about pressure head in the subsequent videos, which is another form of expression of pressure, but in terms of the length of a fluid.